okay? Probably good news for most of you. I'm assuming that you're okay if we move away from fractions. So we will be moving away from fractions here for a couple days. Actually, we're getting close to the end of what we're doing in this chapter. So we're actually going to start getting ready for like a chapter test or quiz because we only had a few sections that probably call it more of a quiz than a test. So we'll probably test early next week. So probably like Tuesday or something. So on the fractions and then what we're doing today. So now we're actually getting into some of that algebra stuff that I prefer, even of being a math teacher, I prefer this over fractions. And just a reminder with the virtual Fridays, they did decide to have the virtual Fridays keep going until at least mid-February, then they'll decide again. So like if you, I always put my calendar over here so you kind of know what's going on. Add it here. So the 19th we just have off. It's like a day for teachers for us to have meetings. So at least the next 4 Fridays are still going to be virtual. Now with virtual Fridays, the way that works, especially in here, is we get homework every day. If you're behind on homework or you're struggling in the class, like maybe you took a test and it went really poorly, that's going to be a time I'm going to require that you guys meet with me virtually to make sure you're understanding. Now, if you're staying on top of homework and tests and quizzes are going well and it seems like everything's going fine, that's going to be off for my class. But again, so if you have missing work, I'd be asking you guys to meet with me just to kind of touch base. If you're struggling, we might meet a little bit longer to work through some things. It kind of just gives us a chance to be maybe one-on-one or just kind of like just getting that extra help. So that's for Friday. So I would let you know, I guess I'm supposed to let you know by today after, or I think, yeah, like today or tomorrow, let you guys know that if you need to meet on Friday. Most of you guys so far, 100% on homework, it's all going well, so you shouldn't have to. But if for some reason you'd like to do the homework the next couple days, I'd probably ask you guys to meet with me. If you have missing work, try to get that in so then you don't have to meet with me. So those of you guys who are maybe even absent or are trying to get caught back up, make sure you do that before like tomorrow's class. And you're always welcome to come in and with me during AR except for Wednesdays. So since Wednesdays is typically ACT, that's the only time you can't come get help. So you guys are always welcome to come in and work with me during AR. Or if you just even want to work in here on your homework and make sure if you have questions you can ask, you're welcome to do that. And some of you guys have me for AR, so you're already in here. But all right, any other questions or any questions? All right. So we'll get going on the notes there. There's a warm-up question. It's asking you to evaluate it, and it has parentheses, exponents, a whole bunch of stuff going on. So you guys want to look at that warm-up question? since I'm someone that's all about numbers, today's date's one of those really cool dates because it's the same way both ways, like you go, it's not working. It's the same way both ways, however you write it. Turning it off and on is the way to fix it. So it goes, like if I don't put the things between it. Oops, I did it wrong. Oh wait. This board is really being finicky. So 121. Right, this is, no, that doesn't work, right? It's the 20th, okay, that's what my issue. Thank you. I was so excited about being the 21st, but so, right? Yeah, it's one of those, yeah. So it goes either way. Whoops, wrong one. Man, I'm like not on my A game here this morning, I'm sorry. Supposed to go, it has been a lot cooler had I not messed that up like 4 times. So, evaluating this expression, this is something I do this every year, and I'm always curious to see how many different answers I get. Good morning. And part of me like secretly kind of wants some of the wrong answers to show you guys how important it is that we all follow the same rules. So, if you look at this problem, and I feel like sometimes things like this go around on the internet, like, what's the answer to this? And I think I always get tagged by like former students to see like what is the outcome of the answer. And this really has to do with something called order of operations. So I'm curious to hear what you guys got as answers because, like I said, I usually get a whole bunch of different answers, and usually, obviously, there's only one right answer. So. Anyone want to venture a guess and think they got the right answer? Even if you don't think you have the right answer, I want to know what you guys get. So Griffin, 8 you got? All right, I'm going to write them over here. You got 0, 0. I know I saw other answers out there. Don't be shy, because I actually don't ever remember what the actual answer is. Yeah, what you get?
Tori's raising her hand.
Tori, oh, thank you. You got 32. I know I've seen 32 around a couple times. Others? I saw 12 out there. Does someone have 12? Oh, I see 12. 12, yeah, I know we saw 12. And I'm trying to use my poker face, not trying to give away anything, whether or not I saw the right answer or not yet. The mask helps with my poker face. See any other ones? Come peek over your shoulders. Let's get 30. Anyone else willing to be told and tell us what they got? So I'm not saying any of these are right or wrong, or obviously some of them are wrong because we can only get one answer. All right, so in order to do this problem, we have to use the order of operations. So at some point you've learned the order of operations. So what is that? Yeah. PEMDAS. So I'm going to write it over here. Again, it's right here. Now I might write it a little bit different than you've seen before. I don't know. I always forget to ask the middle school teachers if they teach it this way. I always put the M and D and A and S on the same line, and we'll talk about why that is in a second. So, my board is really being bad today. So parentheses is the first one, which means I'm going to do all the parentheses first. So I'm going to do whatever's inside the parentheses as my first step. So I'm going to go to that part first. But inside that parentheses, I have to follow the order of operations. So the next step is exponents. And then the m and d are multiply and divide. Does anyone know why I put those on the same line? Yeah.
Because if you're left over with multiple and division, it doesn't matter if you do division first or multiply.
Does it not matter, or like what, like
if
let me show you just a quick, and maybe this will help you explain it.
yeah.
Okay.
It doesn't matter if you do like 2 times 3 first or 12 divided by 2, you still get the same answer.
Do you? Because if I do this first, I get 6. 12 divided by 6 is 2, or I get 6 times 3. So in this case, what do I have to do? So it does matter. So like I guess that and that's okay because again, we haven't had this in spring, so it's okay. Does anyone know what we should do first in this case? Yeah. Multiplication, because it's first in the steps. Do you guys agree with her? Did anyone try putting that in your calculator? This is actually a huge misconception. Yeah.
Technically, you do division first because it's actually in the parentheses.
Well, on this one, yes, but like if I was trying to do like a different problem up here. So in this one, so the question was, should we do multiplication or division first? And like I said, this is a huge misconception. I feel like I always have to break this every year. You actually, the reason why these are on the same line is you actually do them left to right. So you actually do this first. So you do 12 divided by 2 first. And again, that's a huge confusing thing that a lot of students do wrong. And like at some point, maybe someone taught you that, or I actually taught with a teacher who was a high school teacher, super smart lady, and she was teaching this wrong. We kind of had like a math argument about it. You know, like that's what math teachers do, is we just argue about math things. But so 12 divided by 2 is 6, times 3 should give you 18. And if you check that in your calculator should tell you 18. I think if your calculator is a smart one. So hopefully it is. So that's a huge misconception. That's why I put those on the same line, to remind you to do them left to right. So if you need to like put like a little arrow, a little note there, that's something that's a big mistake that students make. And I'm not trying to like say any of you like don't know what you're talking about. It's just something that you probably just mixed up in your brain, and it's easy to do. So we want to do that left to right, and then addition and subtraction, same thing. So that's why they're on the same line as well. So same thing with addition and subtraction. That one's a little bit more interchangeable as long as you're careful about that. So going back to this. And that's kind of like, so in that one, we do want to do the division first because division is more important than subtraction. So we're going to do 6 divided by 3 first. And I'm going to leave everything else alone. So 6 divided by 3 is 2 minus 2. So all I did was that one little step. We still have to do the inside the parentheses. So 2 minus 2 is 0. Okay. What's our next most important step? Yep.
The exponent.
The exponent. So yeah, we need to kind of go back to the start here and say what's more important. So really technically you don't need the parentheses anymore. This is just multiplication. But now next is exponents. So I have to go in and do that exponent. So that's going to be 36. Careful, 6 squared is 36, not 12. And I'm going to change this to multiplication if that's okay. So 2 times 0. Great. Now next, what do you think? Yeah.
You do 36 divided by 2.
Yeah, we can go in and do the division, and really we can kind of go in and do all the multiplication and division, just like left to right. So this is not when we switch this over. So I want to do this, this, and that. All the multiplication and division has to get done before I do addition and subtraction. So 36 divided by 2 is right for Lucas had said that. Minus 3 times 2, which is 6. Plus 2 times 0, 0. some of you guys are trying to change your answer really quickly now because it's kind of getting obvious. So now that we went and did all the multiplication and division, now we just have addition and subtraction, and we're just going to go left to right with it. 18 minus 6 is 12, plus our 0 ends up just being 12. Give yourself a gold star. But again, this isn't trying to like make you feel dumb or anything like that. It's just really trying to get you to realize that these order of operations is so important. The details are important. Just like if I was giving you guys directions to my house and I was like, hey, you can go in any order. Like, I mean, obviously, order matters. I can't say, like, you know, you leave the high school, turn right, and then turn left, and you're like, oh, I'm going to go in a different order. Like, that would be really confusing, and you wouldn't get to the right place. So, same idea here is we're all trying to get to that same right place. So, it's getting used to that order of operations. So, hopefully that kind of broke some misconceptions if you had them, or reminded you of that. So, we're going to talk about like terms and distributive property today. So the first word we're going to define is something called the coefficient. Too many piles of stuff. Leave something somewhere and lose it. Okay, so we're talking about something called the coefficient, and I'll give you a little example here. If I have 2x to the 5th, does anyone know what the coefficient is? Which part is the coefficient? Yeah. What's that? That's the variable. So no, it's okay. It's okay. I know, like all these words, it's not like you use the word coefficient like, again, at lunch with your friends. So coefficient. X is the variable. The 2 is actually the coefficient. So x is considered the variable, 5 is the exponent, and then 2 is considered the coefficient. So it's the number being multiplied to the variable. So in this case, 2 would be the coefficient. Now I'm really not often very picky about using a term, like using a vocabulary word. But coefficient's one of those that there's not a good word to replace it. It's like calling it the number on the front is like, it makes us sound a little like we don't know what we're talking about. So coefficient is a word that I kind of expect that we kind of use and are comfortable with. And it's going to be useful in what we're doing today with our like terms. So, so knowing that 2 is the coefficient is going to be helpful as we work through these problems. So first we're going to talk about, another thing we're going to talk about is what is a like term. So like terms. So I'm going to explain what like terms would be. So like terms are values that have the same variable. So like they both have an x would be like terms. Or they have no variable at all. Or they have the same exponent on the variable. So these are the 3 things that determine if something's a like term. here, we're gonna kind of do a little quick example. So I'm gonna write a few values down and we'll kind of determine what is like terms. So, in this little box here, I drew a bunch of terms. These are all terms. So if you want to write those down, and if you have room in the side of your page or maybe in the margin somewhere, if you just want to kind of follow along, that's fine. So my question is, which ones are like terms? So which ones would we put together? Which one are the ones that we can combine? Go ahead, Clayton.
5x and 3x.
So the 5x and 3x.
And
You want to add more to that?
sure, the 6 and 5 go together.
Okay, so let's stick with what are other like terms. Are there any other like terms with the 5x and the 3x? Does anyone want to add any more to that group? So I would venture to say there's more that should go with those. Yeah, Lucas?
Negative 7x.
Yeah, so that one should go as well. So I'm going to circle it.
Or negative, just the negative x.
Just the negative x is also a like term. What's this one's coefficient? What's the number that should be in the front?
Oh, 1.
Yeah, it's like a -1, so that is still a like term. Does anyone want to put something else with that? Yeah, go ahead. Yeah, x over 2 is actually also a like term. This is really like a 1/2 x. That's also a like term. Does anyone else want to put something else with these guys? So we agree the 4x squared is not like them because it doesn't have the same exponent. So then getting into your other point, what else do you want to put in another category?
The 6 and 5.
Yeah, so the 6 and 5 are also like terms with one another. So 6 and 5 are numbers that don't have variables at all, that those would be like terms with one another. So the circles are a set of like terms, and then the boxes are a set of like terms. So kind of being able to identify what is a like term is going to be important. Because we can combine like terms. So we can put like terms together. I'd be able to put those together. It's kind of like mixing things that make sense. So when we combine like terms, we're going to add or subtract like terms only. So we can add or subtract like terms, but only like terms. So I can put them together if they're alike. But when we add or subtract those like terms, we're going to add or subtract the coefficients. So you're going to add or subtract the coefficients. So those numbers in the front. So that's all we're going to change about these as we go. So we'll do a few examples down here, and we probably will do some whiteboards again today, because these are important that we kind of make sure we're getting the ideas of combining the like terms together. So in example 1 here, what can I put together? Yeah, Clayton?
17a and 4a.
Yeah, and then stop for a second. So 17a and 4a, we can put those together because they're like terms. They have the same variable, really technically the same exponent of the variable, there isn't one. So 17a and 4a, we add or subtract the coefficients. So they're both positive. So 17a and 4a is going to be how much? 21a A. And I appreciate you just saying A. Every once in a while, a student wants to make that like A squared, but you just leave the variable as it is. That's how many A's we have. What else can we do here? Yeah, then we have other like terms here. I'll change colors. So this 9 and this -3 get to go together. And again, I like that you said -3, that sign of that number is so important. So it's really like a positive 9 minus 3. So what are we left with?
6.
6. What kind of 6?
6.
It's going to be a positive 6. So we're going to write plus 6. Now, every once in a while, I have students say, well, I'm not done yet. I can put those together. No, don't go too far here. So we can't put those two together because they're not like terms. And at this point, we don't really know what A is. Like, they didn't tell us anything about A, so it's not like we can solve this any further. This is as simplified as it gets. So we just get to stop here. All right, see if you guys can figure out this next one. We got some exponents going, so that probably freaks you out a little bit. Don't try to do anything fancy with the exponents. We're just combining like terms. So I'll give you a second to look at it and try. Look at the like terms if it helps put circles or shapes around them. Put those together. Give you guys a second. This one has a little bit more complicated things going on here. I want you to take the chance to figure it out before I tell you the answer. That looks like a much healthier choice this morning. This is far away from a monster and what else you were eating yesterday.
Oh, so much healthier.
Right.
We don't talk about like everyone can. What's wrong with in this situation?
For a while, I was in a bad habit of drinking those like Starbucks, like Frappuccino things every day, and they have so much sugar. Like, it just, I mean, they're yummy, but like, so I've cut the cord.
Yeah, I'm just eating, haven't had drinking a lot of Monster.
Yeah. No, it's, I mean, because Mr. Nami used to drink Monster all the time, and like, when he didn't drink it, like, he had headaches and stuff, and so he just, I think, like, the fact that,
I only drink like one a week.
yeah, no, because it's definitely addictive. Like, caffeine addiction's a real thing, so, yeah, he's kind of big on not having any kind of vices like that.
Yeah, that's the only drink that Mr. Mom can get me off then.
Oh, jeez. Yeah, no, yeah, no, it's for sure, for real. All right, so what do you guys want to put together in this case? What do you think? Yeah, go ahead, Lucas.
The 12c squared and the 8c squared.
And what kind of 8 is that?
It's a negative.
It's a negative, very good, or it's like a minus. So that 12c squared, and it's really like minus 8c squared, so that sign kind of sticks with that. So what do I get then?
4c squared.
4c squared, very good. So all we did was combine those like terms, so we just did 12 minus 8. The variable just kind of comes along for the ride there. And then the other part, did you guys catch what you needed to do in this one? And then what did you get?
6c.
Where did the 6 come from? Because I only see a 5c and then a c. Where's that 6 coming from? Yeah, very good. So there's really like, there's supposed to be a 1 here. So it's supposed to be 5c, and then there's like a 1c. If you just don't write that one, it's just not necessary. Everyone who knows math assumes that's there. And when you're first learning it, obviously, it's a little bit tougher. So 5 and 1 is going to be 6c, and they're all positive. So plus 6c. All right, questions there? All right, so we are going to do whiteboards again today. I promise we won't do them every day, but I think it'll be good for us to practice this a little bit. If this half of the room wants to go grab them. Yeah, no problem. like a lottery, get a new board with new interesting things written on it. Next word can go.
Yeah, I thought it was an orange.
Yeah.
I was gonna be like, hey, you okay then? You just hear this whining. Just
Yeah.
you just maybe it's not right. You just start or we're gonna get a hammer.
Guys are not good.
Why would you use all these heads like is it all these heads like
There's a lot of words on there.
Yeah, red midget mama. No.
Who did?
Someone put your friend on that.
Yeah, red midget mama.
So we talked about, we were talking about this, that someone was a little bit maybe negative and then someone turned it into the box. Well, no.
oh that was orange. That was what I had yesterday.
Yeah.
I see it now.
I know, and someone's like, we'll fix that, so I appreciate that.
Yeah, it's you like to
Yeah, close. Just grab a board.
connect
To find an interesting one. Now they're like all into finding a good one. Oh, funny.
You just have to go first. Oh, you would.
There's one over there that you're talking about has like a cross. So someone fixed it into like made it like
I gotta see it.
oh yeah. I do appreciate there's no male parts. Some people get kind of hooked up on wanting to draw male body parts, and there's none of those on there, so don't be the start of that.
It was like, said, well,
I didn't get the joke.
a lone person, something and then it was this.
I mean, yeah, it used to annoy me that people had graffiti on here, but and now they're kind of away. Right. Yeah, it's like unique.
Sell these on eBay.
And I've only I bought these when I started teaching here. I've only taught here for this is my 3rd year, and so yeah, they've come a long way. So, all right, guys. So we're gonna do some combining like terms. So I want to make sure this is comfortable before we move on and make it a little bit tougher. So our combining like terms here. So we're just gonna simplify. It seems like a lot of you guys have the idea down, but I just want to make sure we're kind of all there. So, all right, so simplify, rewrite that. Bless you. You got it. Just be careful about the signs, like so the signs of the numbers. You got it. Just careful. This one's negative. So that's going to change. Yeah, that looks good. No, that's it. It's just you don't have to write all the, I mean, but that's fine. It's not wrong to put parentheses in there. You don't have to. They're not necessary. You got it. Good work. So just Yeah, you're good. And the order doesn't matter, so don't freak out if you see somebody else's written in a different order. You're good. You're good. I'll show you guys all the different orders we can write with this. Yeah. Only thing is you're missing your X. Yeah, don't forget that guy. Yeah, you're good. You're good. What is that? Well, there's like, sometimes people will argue that you can write it. There's two orders, but there's different ways to write it. So like if you look, like these two guys have it written slightly different, but like guys, people have it written slightly different. So I'm going to talk about this because I didn't see it from everybody yet, but okay, so let's look up here. So if this didn't go well, guys, take a minute to look up here. So this is a 5 goes with what? The 7, the positive 7. So 5 and 7 together is going to be 12. So if it helps to circle them, that might be a good idea to tell you that those two go together. Then these two are left over that are like terms. So 2 minus 3 is a negative 1. So you could write this. I saw some of you guys write plus a negative 1x, and that's fine. Some of you just write 12 minus x. All of those things mean exactly the same. So it's okay to write any of those. Or some of you guys got crazy and rearranged the order. So you could have a negative 1x plus 12, negative x plus 12. Any of these are fine. I don't know if anybody had anything different. But all of those are all the right answer. Any of those are perfectly fine. Okay? So at this point, I'm not worried about like the order they end up in, or kind of like what notation you use. Whatever you're most comfortable with is fine. All right, let's try. Yes, good job. We got it. Yeah, this one's a little bit tricky with the positive negatives. Yep. We got it. Yeah, you're good. Got it. This is the 5 1. This is a positive 2. That negative is with the 4. So 35 plus 2. So you're kind of looking at the number, the sign right in front of it. You're good. And guys, feel free to grab a calculator. If you're not great at adding and subtracting positives and negatives, it's fine to grab a calculator. Yep, that's good. Got it. Negative 4 plus 1. Be careful. Oh, it's a negative 4 plus 1. Whereas these are both positive. This is 5 plus 2. So in this case, you guys, careful. So we have a 5y is positive. It needs to go with the 2y, and that's also positive. So those are both positive. So I'm really doing 5 plus 2y, which gives me 7y. Then I'm left with this negative 4 and a positive 1. And this is where some of you guys went wrong. Negative 4 plus 1, think about it this way. You lost, it went down 4 degrees this morning, and then it went up 1. We still are down 3 from where we started from. Or you lost $4 and then you found one somewhere, you're still down 3. So the down has to be like the fact that it's more negative than positive. Again, if you're not great with the negatives and positives, it's okay to grab a calculator. Check your work and make sure you guys are getting those correct. Now, I do want to mention, some of you guys wrote it plus a negative 3, and that's perfectly fine. I don't prefer one over the other. I just tend to stick with fewer signs, but it's not Like, it's whatever you guys are most comfortable with, it's fine with me. All right. Get crazy and throw another term in here. So, I know, it's like getting wild up here. A little bit more going on here. You got it, good work. Only thing is you just want a plus there just so that I know that those are being added. I think it should be positive. Yeah, then we got it. So you can still put those two together.
Oh, that's right. Yeah, I can only get two those.
Oh, yeah, go ahead and I'll show you something else. You got it. Yes, you got it. And then the only other thing is this a 9, right? Yeah. -2. Oh, this one's not a like terminal with it. This one doesn't X.
Oh, I didn't see it.
Or Y or whatever the variable is. So you just need the plus sign that it is positive. In order to seem necessary, we want to make sure it still has that terminal. You got it. No. Your X term is wrong. And did you see the -3 on the end? So there's a negative. No, because that's a negative X. So it's like a -1X.
Oh my god, I didn't register.
No, that's okay. That's why we talk about it. I think you're a little bit off here. This one's a tough one, so it's not going super well. We got good here. You got it. All right, let's talk about this one because I see a few that we need to fix here. So let's look at this. So let's look at the 9 and the 2. What kind of 2 is that? -2. Those are like terms. Those are the only ones without x's. So 9 minus 2 is 7. And again, if it helps to circle things, do that. Because that 2 is negative with that sign in front of it. And then now you hopefully won't use that negative again. So this just, that 2 is stuck to that, or that 2 and negative are stuck together. Now I have to put these together and then this with them. So this is a negative x, so it's really like a -1x. So -1 plus 5 is what? -1 plus 5 is really like 5 minus 1. So 4x. And then we still have this minus 3x. So I could put those two together, and that's going to be 1x, right? 4 minus 3 is 1, positive. Or you can just write 7 plus x. But you do need that plus sign in between them, so I know they're not like connected. So you need to show that they have some sort of sign between those. Okay, or you could have x plus 7 as well. All right, let's do one more here. Yeah. Yeah, that, I mean, that's fine. It's probably a good reminder anyway. Yeah, you're good. Only thing is these are both negative. That's with multiplying. Now adding, you go negative. I know. There's adding and multiplying rules here that are getting confused. You're good. Well, you forgot the y in the front. There's one more y in the front. Don't forget about that guy. You're good. 7y is good, but those two are together, right? That's what, I thought that's what you meant to do, but I was. Yep, you're good. You're good. Close. Did you forget about this guy? Oh, yes. 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 Hang on in front. Forgot about him. Yes. Did you forget about the y in the front? No? Are you sure you did? Check your adding. You're good. You're good. Yes, yes. You good now? Yeah. Yeah. Oh, no, you're 6y and you're adding one more y, yeah? So that's going to be 7. But then your hammer goes together. So, no, that's okay. So guys, in this case, we have this y, we have this 4y and 2y. We have all these y's we can put together. Remember, this is a 1. Don't forget about that one. 1, and this is a positive 4, positive 2. 1 plus 4 plus 2 is going to be 7y. Because this is 5 plus 2 is 7. And then we have a negative 5 and a negative 2, down 5, down 2 more. Don't get the multiplication rules mixed up because we multiplied yesterday. This is adding, so we're going more and more negative. So this is a negative 7. And then we can't put those together because they're not like terms. All right, guys, why don't you guys clean up boards? Why doesn't this half of the room start taking them back? Let's get a brace and put those back. We'll flip the page over.